Welcome to The Explainer. We are jumping right into a digital autopsy today. See, we're looking at a massive, literally catastrophic architectural flaw that's happening right beneath our screens, one that threatens how we process truth itself. And, of course, we're going to explore the mathematically pure solution designed to actually fix it.
So I want you to picture this for a second. What if the very mathematical foundation of our web is collapsing under its own probabilistic weight? What does that actually mean? Well, it means instead of using exact, reliable math, our modern systems are increasingly just making highly educated guesses. We are rapidly moving from a thriving, human-authored open web to a closed, AI-gated reality where mathematical truth is just being crushed into these endless, lossy approximations.
And that brings us to this chilling quote from our sources. Google is a snake eating its own tail. This perfectly establishes the massive macro-level stakes of our investigation today. We're basically looking at a built-in paradox, where an answer engine is mathematically destined to consume its own lossy, degraded food supply. But how exactly does this computational rot happen? And more importantly, how do we escape it?
All right, here's our roadmap for the explainer today. 1. The Python's lunch paradox. 2. The lossy math collapse. 3. The LIFO deterministic solution. 4. Single entry at index 0. 5. Bypassing exponential complexity. And finally, 6. Absolute digital truth. Let's get right into it.
Section 1. The Python's lunch paradox.
Okay, let's dive into this massive theoretical concept. Notice the geometric bulge in this network. In holographic models of black holes, researchers use these tensor networks, which are basically complex, multidimensional maps of information, to chart out space and complexity. The Python's lunch describes a scenario where information gets hopelessly trapped inside that bulge, squeezed between two minimal surfaces. Reconstructing data from this space isn't just difficult, it creates this absolute exponential traffic jam of computational complexity.
To actually recover data from that massive bulge, theoretical models show you have to rely on exponentially hard algorithms, like Grover's search. Think of Grover's search kind of like rolling thousands of dice in a chaotic storm, over and over, just hoping they eventually land on the exact right answer. This frantic, probabilistic guessing contrasts so sharply with verifiable, deterministic truth. Because deterministic truth isn't a fistful of dice, it's a lock with a single, guaranteed key. And that exactness? That's exactly what we're losing in modern computing.
Which brings us to Section 2. The lossy math collapse.
The crucial takeaway here is this staggering figure, 80 to 90%. That is the estimated percentage of AI compute cycles currently relying entirely on hardware approximations, not exact math, approximations. When massive large language models do their heavy lifting, they aren't calculating absolute certainties at all. They're using hardware that fundamentally just guesses the nearest mathematical truth.
And this guessing game happens because of a microscopic piece of hardware called the FPU gambler, or floating point unit. To process absolute mountains of data at blistering speeds, the FPU just estimates math. The hardware literally chops off the tiny decimal fractions of numbers to save time. Our sources call this destructive process the 23rd bit chop, or the wood chipper effect. It acts like a giant blender, permanently destroying the exact original value and crushing continuous human concepts into a digital smoothie. Once that happens, the true forensic traceability of human authorship becomes mathematically impossible to reconstruct.
Section 3. The LIFO deterministic solution.
Now look at the stark contrast here. On the left, we've got the complex, lossy guessing of traditional, top-heavy structures. This looks and acts exactly like that chaotic Python's lunch bulge we saw earlier. But on the right, we have the mathematical anchor. To fix this probabilistic rot, we desperately need a system that entirely abandons guessing and instead proves the absolute state instantly. The architectural pivot required here is moving to a LIFO JSON state tree. And LIFO is beautifully simple. It stands for last in, first out. This requires grounded sovereign stewardship at the very root of the data. By pivoting to this specific architecture, the very last item to go in is always the absolute first item to come out. Meaning, you completely bypass the floating, lossy digital ether and all those chaotic, tangled structures that trap information in the first place.
Section 4. Single entry at index 0. Let's see how this actually works.
So let's look at how this LIFO structure processes information so cleanly. It basically acts like an uncompromising bouncer at a club. This mechanism is known as the sin kernel function. Step 1.
This bouncer sequentially checks the very front of the line to see if the space is empty. Step 2, if it is, it synthesizes the new data directly into that open slot. But step 3 is the real kicker here. If data already exists there, the bouncer firmly and violently rejects the conflicting input, completely preventing any chaotic, accidental overwrites, no exceptions.
Because of this strict bouncer, you unlock incredibly efficient single-entry bookkeeping. Just think about it. This bouncer doesn't care about scanning the massive, chaotic history of the line wrapping around the block. They only need to look at the ID of the person standing directly in front of them right now. By querying only the absolute top of the stack, index 0, you instantly achieve flawless proof of state. And here is the absolutely crucial connection. Because you only check index 0, there is zero exponential guessing. There's no Grover search required to dig through a chaotic bulge of data. You bypass the Python's lunch entirely.
Section 5. Bypassing exponential complexity.
We achieve this incredibly clean bypass by anchoring to a specific protocol called ERC7827, which introduces value version control. This completely replaces probabilistic guessing with bit-perfect tracking. It actually transforms standard JSON into a rigorous smart contract layer. And crucially, it avoids that FPU wood chipper effect natively. Why? Because it doesn't calculate lossy floating point math at all. It proves state by simply checking the version length at index 0. You're counting discrete, exact items, which definitively tells you right away if a digital promise is open or closed, flawlessly locking down the exact record of human sweat.
Section 6. Absolute digital truth.
The visual of a tree perfectly captures this divide. And honestly, seeing how this abstract math translates to the physical world is a genuine wow moment. The Cosmos is the abstract global internet. That's where our digital state securely anchors its roots using that LIFO stack we just talked about. Meanwhile, the local is the tangible edge network, literally the actual physical hardware sitting right on your desk. We securely anchor in the Cosmos, preparing for completely deterministic physical execution straight down into the local environment. And the Flow X42 CheerBot physically embodies this exact reality. It's a localized microhost that bridges what we call the semiotic gap. In simple terms, bridging that gap means translating digital code into physical, real-world action flawlessly. If you rely on traditional event-driven programming, a single delayed signal can ruin an entire physical sequence. But because the CheerBot relies on the absolute truth of index 0, it achieves pure, deterministic execution. The state is either mathematically true or it isn't. No guessing required.
So we fundamentally mapped both the crisis and the cure. We've seen how the LIFO architecture bypasses the exponential guessing of the Python's lunch, ultimately restoring verifiable exactness. So I'm going to leave you with this to ponder. As our legacy systems continue to eat their own lossy, unverified output, what happens when we finally run out of truth? Will you settle for a web of probabilistic guessing, or will you demand the absolute determinism of index 0? Thank you so much for joining me on this explainer. Keep learning, keep questioning the systems around you, and I will catch you next time.